Okay, this is the lecture 8. Let's come unit 3. So the database management system. The topics are queries, constants and triggers, and schema management. We have gone through queries, constants and triggers. That is, we have covered queries, constants, and triggers in that forms of basic SQL query, union, intersect, and accept, nested queries, aggregation operators, null values, complex integrity constant in SQL, triggers, and active databases. So this we have completed yesterday. Next, the topic to be covered is schema refinement. So what are the topics is problems caused by redundancy, decomposition, problems related to decomposition, reasoning about functional dependency, first, second, and third normal forms, BCNF, lossless joint decomposition, multi-value dependencies, fourth normal form, fifth normal form. So let's see how much we can cover. So schema refinement. So the topic we have to go. This is the lecture 8. So next is, so let's go through the problems like problem caused by redundancy, decomposition, problem related to decomposition, functional dependencies. Let's go through this and little bit of normalization, forms, lossless joint decomposition, multi-value dependencies. Okay, what is schema refinement? Schema refinement. Normalization is used to eliminate to reduce redundancy. Redundancy means duplicate copies of the same data. So what is schema refinement is? Normalization or schema refinement is a technique of organizing the data in the database. It is a systematic approach of decomposing tables to enumerate data. Redundancy and undisabled characters like insertion, update, and Deletion anomalies. The problems caused by redundancy is a refinement approach is based on decomposition. Decomposition can eliminate the redundancy. Schema refinement address the following problems: problems caused by redundancy, problems caused by decomposition, problem caused by redundancy, redundant storage, some information are stored repeatedly. So we have seen normalization or schema refinement are both are the same. So let's see what is normalization. Normalization is a process of recognizing data in the database so that it meets two basic requirements. There is no redundancy of data. All data are stored in one place. Data dependency are logical or related. Data items are stored together. So need for schema refinement in Dbms. Schema refinement, the normalization is used to eliminate, reduce redundancy. Redundancy means duplicate copies of the same data. Schema refinement is just a fancy term for saying polishing tables. It is a last step for considering physical design tuning with typical workloads. That is requirement analysis, that is user needs. The second one is conceptual design, high-level description, often using ER diagrams, logical designs from graphs to table, relational schema. Schema refinement, checking tables for redundancies and anomalies. When we have to treat with schema refinement, we have noticed that the main problem is redundancy. In order to identify schema with such problems, we'll introduce the notion of functional dependencies, a relationship that exists when one attribute uniquely determines another attribute. The functional dependency is simply a new type of constraint between the two attributes. Schema refinement functional dependencies. So let's have a look at the property of functional dependencies. In the case of X, Y, and Z are attributes belonging to the table R. Transitivity. If we assume that X depends on Y and Y depends on Z, then it is clear that X is automatically depending on Z. So reflexivity. If Y is a subset of X, then X is also depends on Y. Arguments. If X is dependent of Y, then for any Z, we have X. Z is also dependent on Y and Z also. Union. If X is dependent on Y and Y is dependent on Z, then X is dependent on Y and Z. Decomposition. If X is dependent on Y, Z, then X is dependent on Y and Z, X is dependent on Z. The first three properties are called Armstrong axioms, which is used for functional dependency, and that is used for schema refinement. Schema refinement refers to refine the schema by using some technique. The best technique of schema refinement is decomposition. Normalization of schema refinement is a technique of organizing the data in the database. It is a systematic approach of decomposing tables into eliminate data redundancy and undesirable characteristics like insertion, update, and delete anomalies. Anomalies refer to the problem occurred after poorly planned and normalized database where all the data is stored in one table, which is sometimes called a flat file database. Redundancy refers to the repetition of the same data. So redundancy is also called duplicate copies of the same data in different locations. So what are the different anomalies or problems facing without an normalization? Problems due to redundancy. Anomalies refer to the problems occurred after poorly planned and unnormalized database where all the data is stored in one table, which is sometimes called a flat file database. Let us consider such type of schema. So this is a flat file database. Here we are having student ID as SID, student name as SNAME, and course ID as CID, course name as fee name and the fee. So S1 is A, C1, fee name, and okay, here all, so this is the fee of 5K, 5K, 10K, 10K, and 15K. Primary keys are SID and CID. Here all the data are stored in a single table which causes redundancy of data, and say anomalies as SID and ST are repeated once for the same CID. Let us discuss anomalies one by one. Due to redundancy of data, we have the following problems. They are insertion anomalies. We may not be possible to store some information unless some other information is stored as well. Redundant storage. Some information is stored repeatedly. Update anomalies. If one copy of the redundant data is updated, then inconsistency is created unless all redundant copies of data are updated. Deletion anomalies. It may not be possible to delete some information without losing some other information as well. Insertion anomalies. If a tuple is inserted in referring relation and referring attribute values is not present in the referred attribute, it will not allow inserting in differencing relation. For example, if we try to insert a record in student course with student number 7, it will not allow. Student table, your student number, student's name, student phone, student state, and student and country, and student age. So here what's happening is student codes with student number 7. So 7 is not being entered. Now the student codes, here the student number, course, and course name. To avoid this, following can be used in query on delete, update, set, null. If a tuple is deleted or updated from referred relations and referred attribute value is used for differencing attribute in differencing relation, it will delete, update the tuple for reference relation and set the value of differencing attribute to null. Or delete, update cascade if a tuple is deleted or updated from different relation and different attribute value is used by differencing attribute in differencing relation. It will delete, update the tuple from different relation and differencing relation as well. So what is referenced and differencing I have discussed yesterday. One is from the primary key and other is from the foreign key table. Decomposition. The process of breaking up and dividing into single relation into two or more sub-relation is called a decomposition of the relation. So breaking up and dividing a single relation into two or more sub-relation is called the decomposition of the relation. When the relation in the relational model is not the appropriate organ form, then the composition of the relation is required. If the database, it breaks the table into multiple tables. If the relation has no proper decomposition, that it may lead to proper, like loss of information. Decomposition is used to eliminate some of the problems of bad design like anomalies, inconsistency, and redundancy. Next, the properties of decomposition. The following two properties must be followed when decomposing a given relation: lossless decomposition and dependent preservatives. So let's see lossless decomposition. Lossless decomposition ensures no information is lost from the original relation during decomposition. When the subrelation is joined back, the same relation is updated that is decomposed. Every decomposition must always be lossless. Dependency preservative. Dependency preservative ensures none of the functional dependencies that holds on the original relations are lost. The subrelation should still hold and satisfy the functional dependencies of the original relation. Types of decomposition, that is lossless joint decomposition, lossy joint decomposition. Lossless joint decomposition again divided into two subcategories, that is lossless decomposition, dependency preserving. So let's see this. Decomposition of relation can be completed in the following ways. That is, type of decomposition is divided into two subcategories, that is lossless joint decomposition and lossy joint decomposition. Again, the lossless joint decomposition is again subdivided into two, that is lossless decomposition and dependency preserving. Lossless joint decomposition. Let's see this. Consider there is a relation R which is decomposed in the sub-relation R1, R2, and Rn. This decomposition is called the lossless joint decomposition when the join of sub-relations results in the same relation R that is decomposed. So let's again go through this, that there is the relation R which is decomposed into sub-relations R1, R2, and Rn. This decomposition, that is decomposed sub-relations, is called lossless joint decomposition when the join of the sub-relation results in the same relation R that are decomposed. For lossless joint decomposition, we have R1 is decomposed, R1 and R2 are decomposed with R3 and Rn. So R, where this symbol like X is called a natural join operator. So R1 is a natural join operator of R2, R3, and so on till Rn. Example, R is a relation having ABC as sets or attributes. So let's see this. So R is a relation, the table name is R, it's having attributes ABC. So what are the contents in this? In ABC, the first row or the first tuple has 1, 2, 1, 2, 5, 3, and 3, 3, 3. This relation is decomposed into two sub-relations, that is R1 has the attributes A and B, and R2 has D and C. So it is like this. So what we are getting is RABC is being subdivided into R1 and R2. This is called sub-relations, where R1 sub-relation has attributes A and B, and R2 has attributes of B and C. So A value is 1, 2, and 3. What are B values? 2, 5, and 3. Again, what are these B values? 2, 5, and 3. C is 1, 3, and 3. Because we have to avoid redundancy, we are doing this. For lossless decomposition, we must have our natural join of R2, which belongs, R1 and R2 belongs to the parent R. Now we perform the natural join of the sub-relation R1 and R2. We get A, B, C are attributes as we have discussed earlier. That is 1, 2, 1, 2, 5, 3, and 3, 3, 3. This relation is same as original relation R. Let's see what is the original relation. This is the original relation. Is this is same with the updated one? Yes. So relation is same as the original relation R. Thus, we conclude that the above decomposition is lossless joint decomposition. Lossless joint decomposition. Are we losing anything? No, it is same. How we are the same, the original is same as the updated one. So we are not losing anything. So this type of decomposition is called lossless joint decomposition. Next, dependency preserving. It is important constraint of the database. In the dependency preservative, at least one decomposed table must satisfy every dependency. If the relation R is decomposed into relation R1 and R2, then the dependency of R either must be a part of R1 and R2 and must be derived from the combination of functional dependency of R1 and R2. Again, I'm reading this. If the relation R is decomposed to R1 and R2, as we have seen earlier, then the dependency for R must be a part of R1 and R2 and must derive from the combination of functional dependency of R1 and R2. So what we are telling here, R1 is dependent on R1 and R2. And if this R1 and R2 are derived from R, so this is called functional dependency. So next, for example, suppose there is a relation where R has attributes of A, B, C, and D with functional dependency set that A depends on BC. The relation R is decomposed to R1 ABC and R2 as AD, which is dependency preserving because FDA, A is dependent on BC, is a part of relation of R1 depending on which has attributes ABC. Let's understand this. Dependency preserving. It is important constraint of the database. In the dependency preservation, at least one decomposed table must satisfy every dependency. If the relation R is decomposed into relation R1 and R2, then the dependency of R either must be a part of R1 or R2 and must be derived from the combination of functional dependency of R1 and R2, as we have seen earlier. For example, suppose this relation of R where A, B, C, D are attributes with functional dependency set A is dependent on BC. The relation R is decomposed to R, that is ABC are attributes and R2AD are the attributes for R2, which is depending preserving because the function A is depending on functional dependency, A is depending on BC is a part of the relation R1 where the attributes are ABC. Let's understand this for the example. Employee project details is the table name. Employee code, employee name, employee email, project name, and project ID. Employee code is 101, 101, 102, and 103. You see the employee code is 101, which is repeated, which is not a part of, this is a part of duplicacy and it is not valid in Dbms. So we go for schema refinement and normalization. Next, coming to employee name, John and John, Rian and Stephen. The email ID is john@demo.com, John at the rate of dmode.com. The projects are 103 and 101, and the project ID is 03 and 01. Ryan project is R04, and the Stephen project is R02. So we see the same person is taking different projects here. In this relation, we have the following functional dependency. Employee code is dependent on employee name, employee email. Project ID is dependent on project name. After decomposing the relation in employee, project, and project details, so the project employee project is as employee code, employee ID, employee name, and employee email. In this relation, we have the following functional dependency. Employee code is dependent on employee name and employee email. So the project details are project ID and project name. In this relation, we have the following functional dependency, that is project ID is dependent on project name. We can see that all functional dependency in employee project detail are either part of employee project or the project detail. So this decomposition is called dependency preserving. Lossy joint decomposition. So the second one is lossy joint decomposition. Consider there is a relation so can the time is up, I think so. So can we start this one from tomorrow? Okay. And I have to keep the attendance, right? Okay, guys, I you understood. Let's continue the class tomorrow.